Going on to topic 4 of chapter 1, we're going to deal with exponents, order of operations, variable expressions, and equations. And our learning objectives: define and use exponents and the order of operations, evaluate algebraic expressions, given replacement values for variables, determine whether a number is a solution of a given equation, and then translate phrases into expressions and sentences into statements. Okay. Now, a couple of vocabulary items here as we start. Here is a 2. And what this is indicating is we're going to take that 2 and multiply it by itself this number of times. How many times? 3. So this simplified becomes an 8. 2 times 2 is 4, times 2 is 8. And what they're showing here, and they're using a shortcut that we use in mathematics, where the factor that we're going to multiply by itself, this is called a base. The 2 is the base. And the number of times we're going to multiply the base by itself, we make it as a superscript, a little 3 up there. That is the exponent. So you need to be familiar with those words because we'll be using them. And when we evaluate that, it becomes 8. 2 to the third, we say. Now, 1 to the 7th, that is timesing 1 by itself 7 times. Well, 1 times 1 is 1, times 1 is 1, times 1 is 1. So 1 to any power is always going to be just 1. Now, here they're showing a fraction that's raised to the 2nd power. So it will end up as a fraction. 6 times 6 is 36. 7 times 7, 49. Now, when they have a decimal inside, and many of you will be checking the results of this with your calculator, remember it's this, 0.3 times 0.3 times 0.3. Now, if you recall from the rules of multiplication of decimals, if there's 1 decimal and 1 decimal and 1 decimal, in your answer, you're going to get 3 decimal places, 1 for each of these. So we can think of what is 3 to the third without the decimal. Well, that is 27. So we're going to need a 0 here and then a 27. And that's what 0.3 to the third is. Now, you'll have practice and your mastery through QuizMe And you can always look at the tutorials up over on the left of your screen, or the right, I should say, of your screen, to help you with some of this. Let's go on to our second item here, where we use order of operations to simplify expressions. And here's where I write the initials, please excuse my dear Aunt Sally. This is just an acronym to help you remember order of operations. Now, when we do things in mathematics, in order for everyone throughout the world to get the same answers, there is a certain order we must follow. And P stands for parentheses or grouping symbols. We do that first, along with exponents, raising something to a power first. Then, once we've done that, we then do multiplication and division going left to right. And if division is first, we do division. And then finally, at the very end, we do addition, subtraction. And again, if subtraction is first, we do that. So let's take a look at these and see if we can figure out the order of operations. Here's a real easy one. This is addition. This is multiplication. So what do we do first? We do the multiplication. So this then becomes 7 plus 6, and now we do the addition, 13. Now for letter F, here we have three items, so to speak, and what do we do first? Do we do the multiplication first, or do we raise the power first? Again, exponents is in the beginning, so we're going to do the exponents. And again, rewriting this is important because where these are sort of simple, just not following the rules will give you a wrong answer. Now our negative is right there. Now notice the base of this exponent is just the 3. It's not, the negative is not included at this stage. So we're going to square the 3 and get 9, and then times 2. Again, we have something very similar to what we had here. What do we do now? Subtract or multiply? We multiply. So this becomes 25 minus 18. And then now we do the subtraction, which is a 7. Now in letter G, they're going into grouping symbols. Here we have brackets, and here's a parenthesis. So the rule is we do the innermost parenthesis first. So we have to do this first, which will be a 5. A negative 3 and a plus 8 is 5. We're now going to multiply it by 6. And here's what we have. Just copying what we have there. 6 times 5 is 30. Now we're going to do this, which gives us 25 times 6. Again, we had to do what's in the parenthesis first, or the brackets. So 6 times 25 is 150. And I'm going to clear this, so if you wanted to copy something down, you would pause it. Now, as we do a sort of a division, and there's other divisions, parentheses, again, you can start up here. You're going to do this multiplication. This is going to be a negative 20. Now we're going to do this multiplication. This gives me a positive 12. A negative times a negative gives me a positive, and there's a negative sign between these. So my top is going to be a negative 32 as I add that. Now this division bar also serves as a grouping symbol. Now, what do we do below here? Well, in this parenthesis here, this is going to become a negative 6. And we're going to divide that negative 6 now in the negative 12. This is going to give us a positive 2 because, let me write it up here, negative 12 divided by negative 6. Again, a negative divided by a negative makes it a positive, and this becomes a positive 2. So there's where our 2 comes from out of there. 2 times 2 is 4. So there we are. And now we do our final division, which is a negative 32 divided by 4 gives me a negative 8. Okay, and remember the answers for all of these are down below. So you can check your work as you go along. All right, we're going to move it up. Because in example 2, we're now going to take various values for the letters and substitute these values to see if you can do this type of work. So let's take a look at this. Now we're saying x is 3 plus, we're saying y is 2 and z is 6. So this is pretty straightforward. So we get 5 plus 6, this will be an 11. Now here the x is 3, so we go 3 times. And here's where the use of a parenthesis is very helpful. Minus z, which is 6. So this is going to be 9 minus 6 is 3. Now notice the absolute value signs here. We're going to do our substitution first. We're going to go 5 times 3, just substituting, minus 2 times 6. So this is going to be 15 minus 12 gives me the absolute value of 3, which is 3. And again, substituting carefully. 5 times z, which is 6, over x, which is 3, minus 3 times, now y is 2, that we're going to square, over z, which is 6. So again, we're going to use this, please excuse my dear Aunt Sally. So this is 30 divided by 3 minus 2 to the second is 4. 3 times 4 is 12 over 6. Now, some of this I might do in my head, but I'm writing it out so you could follow it a little better. So this is a 10 minus 2, which gives us an 8. And I check those, and those are correct. Okay, let's clear this and go on to this. Determine whether the given number is a solution of the given equation. And here are our numbers here at the end. We're going to say that is the value of the letter. With this value in this equation, does it make it true? And another item we should mention at this time, that here, this is an expression. These are all expressions, while these are an equation. So you might say, what's the difference between these? Well, because here they are giving us an equal sign. It makes these part of each side of the equal sign are expressions, but with the equal sign in there, it makes it an equation. And we'll be dealing with this a lot in chapter 2, where we actually go through the techniques of solving an equation. But right now we're just substituting. So we put the 27 there, minus 12. Does that equal 15? Well, 12, yeah, this one is. So that's true. Now how about a 7 here? 12 plus 7, is that 29? Well, this is 19, and this is 29, so this is not true. And then here, let's go 3/4 times 5. Does that equal 15/20? Well, here they can't cancel out, so we get 15 over 4. Does that equal 15 over 20? Nope, so that one's not true. And here, if we put 0 there, we get y equals, let me try that one again here. I see the 0 is used twice. 0 equals, 3 times 0 is another 0, plus 2. So is that an equation? No, that is not. Okay, so not too bad, but again, using your various tools and getting the idea of substitution. Now we're going to write each phrase as an algebraic expression. You'll be doing this throughout our chapters, where you have something in an English paragraph and you need to convert it into algebra so you can solve an equation. So these are important steps. The sum of a number and 13. Well, the key word here is sum. What operation in algebra does this indicate? A sum. Well, we're going to add. And we can use x for the number. We're going to add that number, which we don't know, and 13. So this is a very easy one, but again, you had to identify the word sum. Now, quotient is one you don't hear too often, but it's important. Quotient indicates that there's going to be division or some sort of fraction. The quotient of 42 and a number. All it indicates is that you're going to take this 42 and divide it by this number, which we don't know. We're calling it x. The quotient, again, think of it as a fraction. Now we're going to write this sentence as an equation. Remember, so far this was just an expression. With an equation, we're going to have to insert an equal sign somewhere. The product of 1/3. So again, what operation does the word product relate to? And that's multiplication. So 1/3 and a number. So again, no signs between them indicate multiplication. And the word is translates into equal 9. A number added to 12, a number added to 12 is 14. Now here they gave us some very, very easy ones. You'll be getting your practice in Math Lab, and as you do it at home, to master the ones needed for your quiz meet to get your mastery points. Okay, let's see what we want to identify the base and the exponents, which we did. We went over the order of operations, and I did say this is challenging. And then we defined what an expression was and compared it to an equation. In expressions, we're just simplifying usually. But in an equation, we're going to solve for something. And this is an area that is difficult. But again, as you start to identify keywords and then practice. Again, keep good notes, and then you can study these notes as we move along. 23 minutes.